The nonlinear equation. We have x squared minus y equal to 3 and y squared minus x is equal to 3. If we are taking the first equation here, x squared minus y, and we equate with 3 and we are solving for y, it implies y is going to be equal with the x squared minus 3. So this is important for us to know. Okay, so now if I am substituting this in a second equation, what we have, instead of the y squared, I am going to substitute x squared minus 3 square. So instead of the y squared, here is minus x is equal with 3. And now x squared minus 3 times x squared minus 3, if we are distributing, if we are multiplying, we are going to get as follows. So is a x in a fourth minus a 2 times 3 times x squared is a 6 x squared, and is a plus 3 squared is a 9, is a minus x is equal with 3. And on both sides, if we are subtracting by minus 3, finally we get a x in a 4 minus a 6x squared, and is a minus x plus 6 equal with 0. So those are a very simple calculation. I'm not going in every detail. And now we are looking at this equation here according to the remainder theorem. We already see if we are plugging 1 here, if we are plugging 1 is going to be equal to 0. So now, so let me verify here with the synthetic division. And we are taking here, the coefficient is 1. So cubic is missing is a 0, is a minus 6, and here is a minus 1, and here is a 6. So let's see now. I'm dropping 1 here. 1 times 1 is 1. 0 times 1 is 1. 1 times 1 is 1. Minus 6 plus 1 is a minus 5. 1 times minus 5 is a minus 5. Minus 1 minus 5 minus 6. 1 times minus 6 is a minus 6. And this is 0. So we already see one of the solution of this equation here is x is equal with 1. Okay, x is equal with 1. But what's going to be the y? So now we are plugging here x is equal with 1. 1 squared minus 3 is a minus 2. So y is a minus 2. So this is a set solution. Y is equal with minus 2. One of the solution. And what is the other solution? We already see now we have here x cubic plus x squared minus 5x minus 6 is equal with 0. And now we are solving this one here, and we are looking to apply the factor theorem or remainder theorem. We are going to see the x is going to be minus 2 in this case. So x is going to be equal with a minus 2. If we are plugging minus 2, so we can verify this very easy. So we can see the minus 2 is one of the solution. Minus 2 we are applying here. So, and here is 1, 1, minus 5, we don't have any missing coefficient. And we are moving on. We are dropping here 1. Minus 2 times 1 is a minus 2. And here is a minus 1. Minus 2 times minus 1 is a plus 2. Minus 2 plus 2 is minus 3. Negative 2 times negative 3 is a positive 6. Minus 6 is a 0. So what does it mean is minus 2 is one of the solution. Yeah, but to find out y, we are going again, we are plugging in this equation here up what we have. Okay, so just let me go here. And we are plugging x squared minus 3. So in this equation, so minus 2 squared is a 4, minus 3 is 1. So it's very easy to calculate. So y is going to be equal with 1. So this is here we have a two set solution. But in fact here we are going to get more solutions, which tells me this is going to be x squared minus x minus 3. So there are two other solutions because this is quadratic. We already know. And if we are solving as a quadratic equation, x is going to be equal with a 1 plus minus. I'm taking a shortcut because this is an easy problem. So, and b square 1 square is 1. Minus 4 times minus 3 is minus 12 plus 12. I'm sorry, because negative is positive 12. And divided by 2. And we are looking closely. So 1x is going to be 1 plus the square root of 13, because 1 plus 12 is 13 divided by 2. And the other x is going to be equal with 1 minus the square root of 13 divided by 2. And how we can plug in here to find the y? So we need to find the x squared minus 3. But now this x, so let me square both sides, either one. So I'm not going both of them, I'm going in either one, doesn't matter which one, and the process is going to be the same for both. So let me take, for example, this x 1 minus 13. So let me do some calculation. And if I'm taking here x, excuse me, if I'm taking this x squared, is going to be 1, okay, minus square root of 13 divided by 2, everything square here. So x is going to be equal. So down we already see we have a 4. And what do we have here? Here is 1 square is 1, minus 2 times 1 times square root of 13 is a minus 2 square root of 13. Okay, and square root of 13, okay, everything in the square is going to be just a plus 13. So I'm taking shortcut because I think this is very easy, so we don't have to waste a lot of time. So x is equal, 13 plus 1 is 14. 14 minus 2 square root of 13. And as we see here, everything is even. And we are taking some shortcut, x squared. So just let me see here, because this is x squared, is a 7 minus square root of 13 is divided by 2. But no, y is going to be equal with a x squared minus 3. And what's happening here now? Here is a 7 minus square root of 13 divided by 2. And this is a minus 3 here. But instead of the minus 3, this one we can write as a minus 6 divided by 2. Minus 6 divided by 2, okay? And now, since everything is the same, so y is going to be equal, 7 minus 6 is 1, minus square root of 13 divided by 2. It means x and y, both of them are the same. So the solution 2. And I'm sorry, this is the third solution. And the fourth solution is going to be in this form, because we already proved one of the solution here with the square root. So with in fact irrational roots. So the other solution is if x is equal 1 plus square root of 13 divided by 2, then with the same method we are going to find, so the y is going to be 1 plus square root of 13 divided by 2. So those are the 4 set of solutions as we see here. Okay, so I'm not going to repeat all of them. And how they look graphically. If we want to see graphically how they look, and if we are going in Desmos, they are going to look as follows. So as we see here in the figure. So you can check for yourself.